So today on the BSS 1250 channel, we have this Friden Model F. It doesn't seem to be too common of a calculator. You can see it's the old style design with the black casing and the yellow and black keys, with the black and red control keys, compared to the later design that had the gray casing with the chrome accents and then the white and dark green key combinations. And in the 50s they changed it again to the light brown casing with the dark brown keys. But I think this is like the first style that Friden had, this color scheme. And this is pretty common of the calculators at the time, especially this green key plate. For some reason, almost all the calculators in the 20s and 30s had this green key plate. At least, yeah, pretty much all of them, as far as I know. I'm not sure if that trend was started by Burroughs, because Burroughs had the green key plate pretty early on. Anyway, you can see that this key is out of place. This is what the keys look like on the newer style Fridens. They had this light and dark green on the keyboard instead of this yellow and black. I don't think this is ever going to be replaced, because as far as I know, the Model F is the only calculator that used these keys here. Though it might actually be the same as these keys too, but still, these old style Fridens with these black keys are not too common. And I think Friden is the only one that used this particular shape of key. All the other calculators that I know of either used bigger keys, pretty much bigger keys. Margent used like oval keys on some of theirs, but they're not the right color anyway. So this is probably never going to be replaced, because I doubt I'll ever find a replacement for that. But that's not a big deal. So the state of this machine. The carriage is partially unlocked, and I think this up here is a carriage lock. It doesn't seem to move that much, and that's probably because the carriage is in between lock positions. You can see the arrow here is pointing kind of in between numbers, and you can see how these ones move as I slide the carriage. That's because the machine is partially through a cycle, so we're trying to drive these, and that's why the carriage won't lock into position. So I think what I'm going to do is I'm going to put the carriage right in the middle to hopefully disengage most of these. Well, they're not that disengaged. Hopefully they're disengaged enough that it won't jam if I apply power. Let me get the cord. So I believe this is the original cord, and by some miracle it's still really flexible. Usually cords this old are all dried and cracked and crumbling. Before we power it up, let's give it a once over. To the side, you can see the Friden logo there. This is just like a decal. On the later ones, they actually had a metal badge they put on. And the back, you can see our designation there, Model F, uses 100 watts. It's made in San Leandro, California. You can have the design patent number. So that's where our cord goes in. Some dirt on there. I believe this machine was introduced in 1936. Which I think is the same year as the Model S, but I've never seen a Model S with this case style on it, so not sure about that. Model S doesn't seem that common either. This one, and the same thing, Friden logo on that side. So I think I'm going to just give this a little bit of juice here. We're going to pour it on the back. Now I'm just going to give this just a little bit, just tap it into the plug here. Knock it with a little bit anyway here. Just going to give it a little bit of power and just see what it does. Okay, so it's not jammed. It looks like it's not engaged at all, to be honest. So let's take the back off. So you can see our motor down there. You see these look like little rubber things that are pretty loose. There's our power connector. So let's plug this in and see if we see the motor driving anything. The motor is driving. See its shaft driving there. Can't see what it's supposed to be driving. I think we better take this side off here. See if we can get a better idea. Okay, I think I see the problem, which we probably won't be able to fix. I'm not sure if you'll be able to see it or not. See, this gear is the motor drive gear. You can't see that. So this gear is the motor drive gear, and it looks like it's driving this gear back here. You can see that. Probably not. So there's a gear. So this gear drives another gear in the back here, and it looks like this gear is missing some teeth, which is unfortunate. I don't know why the camera won't show that. You can kind of see it here now, this gear right here. It looks like it is missing some teeth. So let me do a quick little investigation on that, but it's not looking good. Okay. So this gear right here is the one with the missing teeth. What I did, which I'm sure is not going to work, is I'll just spin it around here. That. So I used the ice pick to tap into a little bit so that it'd make a hole, and then I think I also forgot to mention this is a cardboard gear. And I know that sounds ridiculous, but this is not the first time I've seen this. Motion use this too. I think the idea behind using it here was that if the machine jammed for any reason, this would be the weak link that would fail and protect any of the more expensive pieces of the machine, which was fine. Back in the 30s, you just call up your Friden guy and he'll come out and pop a new gear in. I don't have that luxury, so what I did was I used the ice pick, tapped it in a little bit to make a hole, and then used a paperclip, stuck it in the hole, glued it in with super glue, and cut the tips off so that they're the regular size there. The reason why some of these are off-center is because originally I was hoping to get 2 pieces of paperclip in per tooth, but that just wasn't happening. It would have been better to use like a little tiny drill and drill in there, but I don't have that, so there's no way this is going to work. I mean, it works now, but I'm pretty sure that once this is actually under load, those are just going to fly right out. They're not in anywhere near as deep as I would like them to be. And the only problem is the ice pick's too fat, so when I tap it in any further, it starts to split the gear, which is even worse. It's a little bit noisy, but they seem to be all the right size. I think I'm going to do next is go over and make sure all the pieces, different parts of the machine are in working order, because I don't want this to jam at all while listening to you, because if it jams, it'll definitely break these right out. Or it might even break more teeth off the gear. Yeah, there's no way that's going to work. Okay, so let me do some kind of like backstory explaining before I tell you where I'm at right now. So, the motor on the bottom is attached to a shaft that has a little tiny gear on it, and that little tiny gear drives our broken gear, and our broken gear drives this gear right here. This is attached to the main shaft through a clutch. So when the machine's not doing anything, this gear can just freewheel spin. Actually, I can spin it from the bottom. So that gear just freewheel spins when the clutch isn't engaged. When the clutch is engaged, it locks this gear to the main shaft that runs all the way through the machine. And then that shaft is down behind this plate down here. I'm not sure if you can see it or not, but there's bevel gears on the bottom. Yeah, it's kind of dark. But on the bottom of the shafts with the drums on them, there's bevel gears that drive off that shaft. So in my effort to make sure this machine was running as smoothly as possible, to hopefully not bodge my repair on that gear, or my bodge on that gear rather, I turned the machine by hand a few times and noticed that it was pretty stiff at the beginning and end of the cycle. So I went through and was wiggling everything attached to the main shaft, and I noticed that all of these shafts with the drums on, you can see the silver drums right there, those are all pretty loose except for this one right here. See, it's loose now, but it wasn't loose then. So what I did was I took the whole back plate off of here, which released all of these pieces that sit on here. And now with that back plate off, you can see this one is a little bit loose. You can see it moving there. That one is a little bit loose. They should all be just a little, they have a little bit of play in them. So maybe that one had a little bit too. So you all have a little bit of play in them. So what I found was on this back plate here, you can see how there's some crust here. I think this is the one that was jamming up, but also there's some crust on this one and a little bit on that one as well. So when I clean this up and hopefully put it back together, and hopefully that will make our machine run a little bit smoother so as to not break those teeth off. One caveat though is that when I took that back plate off, all these little springs and ball bearings shot all over the place. I think I have miraculously managed to find all of them, and we'll find out when I put it back together. I think there should be 12, and I have 12, I think. How this works is, so these things here are kind of like locks. You can see how I can only turn it a certain amount, and then the flat sides hit on the drum down here. Now I don't know why these are all timed differently. You can see this one is free because the drum is not as high up. You can see the best on this one. You can see how there's this flat here will hit against that octagon, whereas here it's lower, so the octagon is free to rotate. How many more sides that has? I think it's an octagon. Then these things go in here and go in the center of those somehow. I should anyway. Maybe you have to disassemble them. So I'm going to lay that there and put this in here and put that in there. And it should go in the center there, I think. There we go. So now this is attached to that shaft, and this is the detent. That's what that little ball bearing rides on, these little like flower petals here. That's a detent to keep this in place when the octagon is not locking it. So you can see this is what drives the carriage, and this can go up or it can go down, and that depends on whether you're doing addition or subtraction. It goes up for addition to engage with these gears on the bottom of the carriage, and then it goes down for subtraction. This gear here I think is for the carry. Not 100% sure on that, but I think that's what that's for. And then this shaft is driven via a little gear. Actually, there's two little gears. You can see one of them. Where I'm pointing at, you can see one of them right here is one of them, and there's another one up underneath. And which gear is activated depends on which number you press on the keyboard. So I think 1 through 5 move the lower gear back and forth to engage with the teeth on the silver drums, and then 6 through 9 move the upper gear back and forth to engage with the teeth on the silver drums. That's basically how this mechanism works. So far, without these pieces engaged, it seems to be that the biggest sticking point is the the spring on the multiplier. So the multiplier over here, I'm going to drop it. Just don't want to crush my pieces. The multiplier, there's this thing on the side here. You can see these are the multiplier keys, and each one drives a little plunger here. Basically what this does is when you hit a plunger, it will release this ratchet type thing to swing around until it stops. It's stopped by one of these poking in. So like this is 9, 8, 7, and so on. So you hit 1, this is going to swing down 1 position. You hit 9, this is going to swing down 9 positions. And then for every cycle of the machine, it drives this back 1 place. However, when you're just regularly adding, it still nudges it a little bit to make sure it's back home. And that seems to be the stiffest piece of this. Okay, so I put the base back on with the motor in, so we're going to give it a test now. I positioned you from this side so that hopefully you can see when the pieces fly out, which I'm sure is going to happen. So we'll apply power, and we'll just try adding. Okay, so far no explosions. Should we just try slipping the carriage back on and see if that will work too? Just put a little dab of oil on the rollers here. It was on 2 rollers on the front, and then this track on the back. And actually, before I put that on, I'll show you that. So it rides on these 2 rollers in the front, and then this track here along the back. And this track here has, you can't really see them because they're kind of discolored, but there's little screws in there. That's underneath that plate is where all those little springs and ball bearings go, and they serve as detents for these shafts. One important thing to note is that these shafts have different lengths. So you see how these octagons are staggered. So the octagons that are back further get a longer shaft up here than the octagons that are forward further, so that they all line up and then go in the holes in this back plate. By the way, this thing here is the counter drive. This just comes up and picks it forward in position, and then these are all for carries. You can see they spring out, and that's how it carries across the register. So, if that explains, we'll just pop this back on, I think. It should just slide in, I think. Not doing it. Still not doing it. What's going on here? There we go. I think, yes. Should. Oh, this is. Gotta lift that up. And it goes on. Okay. We also have these little things here. And these will just hold it down. It does slide out with these in place, but I took these off since I took apart that rail with the ball bearings in it. So we'll just pop these back on real quick. And there should be another one here. And I wasn't thinking, because we'll put that back on later. Let's try this out for now. Okay. So let's put this all the way in the home position. These should be free. all seem pretty free. Counter seems pretty free. So we can clear those. I think. It's kind of sticky. Okay, so you can get a top view of it here. We'll try 1, 2, 3, and that should come up. Well, you can't see it in the front. Let's just see if it blows up first. Something's not working. Just a minute. So the issue with this was timing of these brass gears. I'm not sure if you can see, but on most of them they have a tooth sticking up right in the middle, whereas this one looks like it has a trough right in the middle, and the carriage gears in their home position are always expecting a tooth to be right in the middle. So because of that, when we try to add and push these up to engage those gears, they wouldn't engage because the timing was off there. So I'm taking all the springs back out. You can see the holes there where they go into. And I took the back off and rearranged some of them, but I think like this one I missed a few, so you have to go back through and rearrange all of those. I think it's supposed to be that when you have a peak, because see this one's locked, and it looks like there's a peak on the top of that octagon there. So I think when you have it with the peak on the top of the octagon, there's supposed to be one tooth sticking straight up. See, not all these are locked. Some of them are free, so it's harder to align the free ones because you're not 100% sure where they're going to lock in. But I think that's how it's supposed to be with the one with the peak on the octagon lining up with a tooth here. So hopefully. Okay, I got the carriage back on. Seems like these will engage. This is pulling up that rack, by the way. That goes all the way up now. It seems to engage pretty smoothly. I can't really show on video the alignment because it's just not going to show up well. But basically, there's 2 of those shafts per silver barrel, and that's why there's 2 levels on the silver barrel, because one is for one column and then one is for the other column. So basically, there's one set of 2 Leibniz wheels in between the columns, and that set of Leibniz wheels services both columns on either side of it. And basically, what you want to do is for the left one, well, on the front it'd be the right one, but looking at it this way, the left one, you would want the pin to be, I guess, like just to the right of the peak of the octagon. You want the tooth to be just to the right of the peak on the octagon. And on the left one, or on the right one rather, you want it just to the right of the peak on the octagon. Seemed to work. I hope that makes sense. So I think we're going to give this a try now. I'm going to lift you up over it. So we'll try 1, 2, 3, and see what happens. Okay, we got a 9 there because something is flipped backwards. Must be that's flipped backwards. Maybe I just didn't clear this first. That could also be. Let's see if it actually added though. It looks like it did. 1, 2, 3. Okay, so let's clear this and we'll try it again. This time from the front. If this goes successful, maybe we'll even try multiplication. So we can try here. 1, 2, 3. I think that's in the right position now. Yeah, so now I counted up 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that didn't last long. So before I explain what happened with this machine, I just want to show a little bit down here while I have it flipped over with the bottom off. So these right here are, each individual one of these is a set of Leibniz wheels. They're modified Leibniz wheels because normally you can see how here the teeth go from a little short one up to a tall one. On a true Leibniz wheel, this would go from this short one all the way up to one that goes the whole length of the wheel. That would be your 1 through 9 pins. On this design, you have your 1 through 5 pins here. So, for example, when the gear engages, down here, it engages with all 5 of these pins. You can see that it engages with all 5 of these pins, versus when it's, up here, it's only going to engage with this top pin. These pins up here are the remaining pins. You can see them better on this gear. You can see that there's, a short one, then a slightly taller one, then a slightly taller one, and then all these 5 here, or I guess 6 of them, all these 6 here are the same length. So 1 through 5 selection is done on the lower set, and 6 through 9 is done on the upper set. So like the 6 would engage with these 6, 7 would engage with this one plus these 6, and so on, all the way down to 9, which engages with all of these. The reason why there's 2 of these on each shaft here, so they move together on the shaft, is because this is for one column and this is for the next column. So basically one of these set of drums corresponds to 2 columns on the keyboard and in the register. And then you'll have, I'm not sure if you can see it or not, but the shafts are down in between these gears. Actually they're up here, you can't really see them, but there's like one shaft that goes right here and then one shaft that goes right here. So like this is one column, this is the next column. And that's how they line up on these shafts. And these flat spots here, see the shiny spot there, that flat spot is what engages with the flat spot on the decagon on those shafts up there. So that's what locks them in place to keep them from rotating at certain parts in the cycle. Still working on repairing the gear. I drilled a little deeper. I used the drill this time and drilled into the gear a little bit. So hopefully these pins will stand a little bit better. We'll see. I'm still not a big fan of this fix, but we'll have to see how long it holds up this time. And then these wires here are just for the switch right here, or just 2 contacts, and then when this pin moves, they'll connect to drive the motor. And then just have the 2 wires here that connect on the base plate. I'll have to see if I can show you that later. This, I'm not a big fan of either. For some reason this column was particularly sticky. Well, I can't move it now because it's sitting on it, but like when you hit a key in this column and they clear it, this wouldn't return. And the only way I could find to get this to loosen up was to bend this tongue out a little bit. So you can see it bent out there. Normally, like on the other ones, it's straight up and down, but for some reason it was binding here. And I couldn't figure out any way to bend this piece to get it to free up. I tried bending this all sort of different ways, and it wouldn't free up. The only way I could get it to free up was to bend this out a little bit. So, not sure what's going on there, but I think that should be okay on that column. So let's put the base plate back on, flip this over, and see if it breaks again. So the issue with this that caused it to jam was timing, but it was timing on these black gears here. These are the carry gears, and when a carry is desired, these pop down and then engage with a tooth on that drum to drive this photo in position, and then they pop back up. The problem was these were out of time, and that was causing it to jam when that tooth came around to hit it on the carry. That's why when we tried it, it worked for the first couple of cycles, but as soon as it tried to carry over one of the columns, then it jammed up because that column, the carry wasn't working on that column. So to time these, you have to have the peak in the decagon has to be in one of the troughs in this gear. I don't know why they made this so complicated. They could have just gone with, instead of square shafts, they could have gone with pentagon shafts, and then there would have been an even number of shaft flat surfaces per decagon face and per gear tooth here and here, and that way whatever way you put it on, it will be right. But since they have 4 surfaces on the shaft, but 10 teeth and 10 faces on the octagon, there's not an even number of teeth and faces per side of the shaft, and that's why it only fits on right one way. And then, of course, there's no marking or anything to let you know which way is the right way. So it's kind of annoying, but I think hopefully it should be good now. I have put the carriage on and turned it over by hand, and it was able to carry all the way across, and then so when I did subtraction, it was able to carry back all the way across. So hopefully it will be okay. Yeah, I think we're just about ready to test this, and I have to wire the motor back up and go to another test. Okay, This time I'm going to keep one hand on the cord back here so that I can pull it off as soon as it jams, if it does jam. So let's give this a try. 2, 3. Oh, it's not doing anything. Why is it not doing anything? Okay, one moment please. Okay, I think it just wasn't properly finished the cycle. Sometimes when I turn it through by hand, because I turn it by this gear, it doesn't have enough momentum to fully finish the cycle on the main shaft that goes through, because the clutch ditch engages a little bit early, which is fine when you're driving under motor power because it has enough momentum to go that last tiny little bit and lock in, but when you're turning it by hand, it doesn't always have enough momentum to do that. So I think hopefully we should be ready now. Got 1, 2, 3. No, still not going. So I think that's the engagement for the those gears that slide up and down. Those seem to be fine, I think. So okay, let me look at this for a minute. Okay, it seems like something just wasn't set right, probably because it had the machine upside down or something, you know, something wasn't in its home position. So let's try it again. Put our hand on the cord back here. Okay, 1, 2, 3. Oops, I don't have it in add mode. Okay, and then if we do 9, 8, 7. 3, 3, 3, 0, that is correct. Clear it. We can try a subtraction. Let's do 465. Try minus 65. That seems to work. So let's try some more advanced functions. Something I'm a little afraid to try is the clear. But it seems to work. That's good. We can try shifting. That seems to work. Should we try multiplication? I think for multiplication we have to shift out. So let's do that. We'll try 25 times 25. So I'll set 25. I'll take it off. Oh, it is off add mode. Did it come off add mode on its own? I don't know. Anyway, we'll take it off add mode. We'll set 25. And if we do 2 here. Oh, it's shifting the other way. Oops. I don't think there's a way to fix that. Let's try clear home and see what happens. Okay, clear it home. 25, so then we have to enter it backwards. So 1, 2, 3, 4, 5. And then 2. 625, that's correct. Good. Okay. I'm going to try more advanced multiplication. We can try 625 times 625. So then we need to first enter 5 again. 1, 2, 3, 4, 5. That didn't sound nice. What happened here? Something did not engage. Jammed again. So I think what's been happening is the pins that I put in become loose or get misaligned, and when that happens, then that's when it jams. And every time that I run this, it keeps losing more teeth off the gear. You can see all those teeth are newly missing. See, it doesn't even want to go past the teeth that I had in there because they get misaligned, and then when they get misaligned, that's when they jam. You can see that one came out completely. There's still a couple left, but I would have to drill all these new holes here for all these new pins. So I think I'm going to have to give up on this. Okay, so I know I said I was going to give up on this, but it's a couple weeks later now, and I decided to try again. This time I drilled the holes out, and they were a lot deeper before putting the paperclip pins in. So we'll see if that helps. As you can see, as I turn this, which is where the motor is going to be spinning, it continuously turns the entire, well, the drive gear down there. It's not driving the machine because no function has been selected, but we'll have to see how well these pins will hold up now with the deeper holes drilled. See, these are the ones that didn't come out last time, so I just left those alone, but the ones down here that did come out last time, I re-drilled deeper and glued them back in. Well, glued new ones in. You can see they're not exactly straight, most of them, but hopefully they'll be okay. The main concern is, one, that they'll actually stay in, and two, that they won't move and jam, because I think that's what happened last time. I think that some of these got a little bit loose or something and then moved in their holes, and then that's what caused the machine to jam. I think what happened initially on this machine was someone had plugged it in after it had been sitting for a while, and the machine jammed because of the corrosion that we found back up here in the register drive. And we found that rust that was causing a high resistance to the mechanism motion. So I think that when someone plugged it in, that prevented the machine from turning. And this right here is the slip clutch. Basically, it works kind of like a lot of the modern drills, where it has, I think it has a set of ball bearings in here, and the ball bearings are spring-loaded, and the input shaft rides up against those ball bearings, but if there's a high resistance this side, it will spin over top of those ball bearings, basically compressing the ball bearings against the spring, and spin over top of them, and then fall down the other side until it hits the next set of ball bearings, and so on. So that kind of creates like a hammering type motion on the output shaft when it's jammed. And I think what happened was, after enough of that hammering motion on this output shaft with the machine jam, that's what stripped the teeth off initially, is what I'm thinking happened. And then the other jams, well, when we put it back together the first time it jammed, that was because I had the carry timing off. So that was that jam. And then I think the last time that it jammed was because these teeth had come somewhat loose, and then the gears couldn't mesh, and that's what jammed it, I think. So I'll put this back together and see if it works any better than last time. Okay, so let's try multiplication, and that's where we got messed up last time. So we want to shift out 2. We'll do 625. Oh, looks like add took itself off. That's interesting. Maybe I wonder if return clear does that? I don't know. This is supposed to latch down, and it's not supposed to clear the keyboard, but it looks like it popped up by itself. So, not quite sure about that. Anyway, let's try this here. So, 625 times 1, 2, 3, 4, 5, 6. And nothing happened. Okay, so let me investigate that. Okay, so it looks like the main shaft didn't come all the way to its rest position. So that might be something we have to look into, but let's try that again. We are shifting the wrong way. I should have known that. Okay, let's try clearing home. Okay, now we have to enter it backwards because I forgot you can't set the shift direction on this. So we'll do 2, and okay, must not have went home again. I'll just budge this a little bit and see if that makes a difference. No. Not sure. Not quite sure why it is doing this. There we go. So yeah, it's just not getting into its own position. So I'll have to see if we can figure out why that is. 625 times 625, 365. Okay, so that was successful. I think the next thing to try is division, and see if that will be successful. So for that we have to shift all the way out. Am I out the end yet? No, I am. Okay, so we'll do 355. Here and here. Divide that by 113. And see what happens. It's not working. Okay, so that I think is just division getting stuck. The last time I played with this, division was not completely stuck, so yeah, it's definitely stuck. Alright, so I'll have to look into why division is sticking, but so far our fix seems to be holding up. Hopefully we'll continue to do that. So let me play around with division for a little bit and see if I can figure out what is stuck there, and then hopefully we can run this machine through its full cycle. Okay, so let's try division again. So we can plug it in. That's all the way out. Okay. Can it lock in this time? I think so. It's still kind of sticky. Well, that seemed kind of sticky too. You know, it's going to take some time for the oil to work its way into everything. That is not the shift button. Why it doesn't want to work on those. Interesting. Unless there's something up with the carry. Let me check that. Let me check, maybe there's something up with it not wanting to carry over that far or something. So it looks like on the pins that I put in the gear, one of them I cut too short. And because it was too short, it wasn't meshing properly with the other gears, and that kind of like wore it down and kind of like mashed it lower a little bit. And so then it wasn't meshing at all with the other gears. And then because of that, the pin that was next to it was getting more force than it otherwise would have. So that one was starting to bend over a little bit, and that's what was causing it to start messing up. So I've replaced those two pins with longer versions. Hopefully that will take care of that. And then as far as the carries not happening, I noticed that, see, these things here snap back up. So this one's still a little bit sticky. Doesn't snap back up quite as fast. When I first started playing with these, this one didn't want to go back at all. It would just stay down, but it's getting a little bit better. So I'm not sure if that's the reason why it wasn't carrying, or what. Because these things go into these little sliders here. You can see that. And they pop them down. And these are detented. So these, when this goes down, it will push this down, and then that detents down. So I'm not quite sure why these not springing back would cause the carrier to fail, but hopefully this will resolve that problem. I'm not quite sure what else the problem would be, because I'm pretty sure it's carriage dependent, because when the carriage is all the way over, you know, for the first couple of positions it carries just fine, and then once it gets to a certain point, that's when it stops carrying. So if it was the carry piece down here, and that's part of the machine, I would think that that would fail wherever the carriage is. But the fact that it only fails when the carriage is in a certain position leads me to believe that it's something on the carriage, hopefully just these, that is the problem. And because these are really all that is on the carriage for carry, aside from the little nubs on each of these wheels. Now, it's theoretically possible that the nubs on some of these could be worn down somehow, and then when you try to carry, it doesn't give enough oomph to these things to push the sliders down into their detent. That's another possibility that I'm not sure of. So put this back together, lift this out. That is all the way out. Okay. So 355 divided by 113. No, the carry's still broken. Carry's still not working. Let's just see if I do -1. So it carries over to here. Actually, why does that one have an 8? That one also has an 8. Did this not clear? Oh, because I have these numbers in there, that's why. Operator error. Let's try that again. 1 through 1 minus. That looks good. And then clears back out, so let's shift this over a couple positions. Wait, not home again. And we'll try the same thing here. And that also carries all the way over. So that's interesting. The carry seems to be working, yet it's not triggering only for certain carry positions. So if you watch up here, this right here, this is the trigger that triggers the overflow. So this is the last carry on the machine. So when this pops down, that will trigger the carriage to restore and shift over. And for some reason, it doesn't do that every time. So if you just watch here, I'll start a division, and every time this pops down, and the carriage won't always shift each time, even though it's supposed to. There, it missed it. Now it's going to get stuck. It's going to get stuck there because it didn't shift when it was supposed to. We are getting very, very close though. 31415. That must have messed up here. Either that or because it was sitting here adding so long, it carried over there. But this should be a 9 here. So the reason why it double taps is because it will. Use my pointer. The reason why this double taps, like jumps down then jumps down again each time, is because the first time is for the subtraction. That'll tell it to restore, like add 1 back. So when it adds 1 back, it'll overflow again, and that's the second bump. And then after that second bump, that's when it's supposed to shift over to the next column and repeat the process. But I think sometimes it doesn't trigger the restore, and then because of that, it doesn't shift over properly. I'll try this again here, make sure everything's clear out. So it broke really early on that one. Get a better one here. I'm not sure if you saw that, but again, it messed up. It's kind of hard to capture the whole movement because the carriage keeps moving in front of it. See, this plate here keeps moving in front of it. So I can try again here. See if they can do it that time. You can't really see it now. So I'm going to play with this for a little bit more and see if I can figure out what is going on, why it's not triggering the carry each time. That carry trip down there is not getting pushed down far enough. See, what happens is when it pushes down, see, it latches in, there's a detent there, and that keeps it in place. And looking on the back of the mechanism, well, let me show you what I'm talking about. So when that carry thing trips, it pushes down on this little bar right there. So watch when I trip it, you should be able to see that go down. Let me move this out just a little bit here. So you can see this bar right here drops down just a little bit. Not sure if you can, yeah, you can see that. So it pushes down just a little bit. Now, in division mode, this rod here is set up like that, so that when this trips, see, it pushes on that other plate there. And what happens is this plate here has a little finger that goes up, and that finger is pushed over by a peg on this silver drum here. This silver drum here is basically what would be a Leibniz wheel, except that the machine doesn't have one over this far because it's not adding anything on these register positions. That wheel is just there for carries. That has a peg on the front of it, so that way when this is pushed up by the carry trip, the peg hits that and pushes this whole rod over, and that's what affects the re-add and then the shift. And looking at this, it seems that the carry that carry trip on the top is not pushed down far enough to latch in, and because of that, this only pushes forward a little bit and doesn't stay forward long enough to get caught by the peg to engage the mechanism. That seems to be the issue. Why it carries early sometimes, though, I'm still not quite sure on, because you notice that sometimes it'll carry too early instead of not carrying, or sometimes it'll shift too early rather instead of not shifting at all. So I'm still not quite sure why that is. But definitely one of the problems is that this is not being engaged long enough to affect the overflow correction and the shift. So I'm not sure if that's because one of the carry tabs on the register is bent. I mean, they didn't look bent when I looked at them, but it could also possibly be that the timing is out, although I'm not quite sure how that would affect it. But I'm going to take the register off and I'm going to double check all of the trips for the carry to make sure that none of them are bent or shorter than other ones. And then I'm going to take a closer look at the timing and make sure that the timing looks to be exactly the same on all the register positions. Okay, let's see if we can get a successful division on this. Yes. Okay. So, how I managed to achieve this is two things. You'll notice that I'm doing the division in these columns instead of these columns. And the reason for that is I discovered that this column is erroneous. It'll add or subtract too much sometimes. Usually only like one more. Like if I put a 1 here and hit add, sometimes it'll add 2 instead of 1. Same thing if I put 8, sometimes it'll add 9 instead of 8. And then same thing for subtraction. I'm not sure why that is, but that was the reason why it was carrying early sometimes before when we were doing it. The second thing is, I'm not sure, let's lower this down, I guess. So, you see these little tabs here, these guys, I'm pointing at them. Those are what do the carry from one column to the next. So if I turn this to 9, you can see how the little tab twitches there. The little twitch is what pushes down on the triggers down inside there to trigger the carry. Now, for whatever reason, it seemed that it would always carry over to the last column, and then that's where it had the issue. It wouldn't always push that slider down far enough to engage the shift mechanism. I'm not sure why exactly that was, but what I did is I just went, and the ones that were having the most problem, I just went and I bent these out ever so slightly, and as you can see, that seems to have resolved it. It now can successfully divide. Why exactly I needed to do that, I don't know. I did notice, though, that when I was putting the carriage back in, sometimes I was bumping these on their sliders down in there, so maybe from taking the carriage on and off so many times and bumping them into there, they got bent out of shape. I don't exactly know, but that's what I did, and so far it seems to be working. Additionally, there is another issue with the carriage, which I'm not sure how it happened, but so if you look, let me get my pointer here. If you look down here, you'll see that there's a very you'll see there's a very slight gap between the brass back and the metal carriage, or I guess they're both metal, the aluminum or steel or whatever it is carriage rail here. There's just a very tiny gap. Now if I move the carriage all the way out, you notice as I get to the end that gap disappears. So you can see gap there, no gap there, versus here, gap both places. So whether the carriage got bent in shipping in some way or what, I don't exactly know. I don't think there's anything I can really do about that, because I'm not sure what exactly is bent, whether the carriage is bent or whether this whole side of the machine is somehow bent out of whack. That I don't know. So for now I'm just going to leave it. It is a bit stiff when you get over to that side though. See, it definitely stiffens up. Another issue is that because of that, these things here can't be tightened down all the way. If I tighten these down all the way, it just locks, so you see the screw there is loose. If I tighten that all the way up, it just locks the carriage in place and you can't slide it at all. So something is definitely out of shape. The issue is I'm not sure what. So I think I'm just going to leave well enough alone in that department. And I mean, it should stay together. I don't think these will fall out on their own. Hopefully not anyway. Also, I'm missing the stop here. That's why it's easy to slide the carriage off. So I actually have the piece that, you can't even see it, upside down. I actually have the piece that goes here, but I don't have the screw that goes in it. When I took this apart, the piece was just laying down in the bottom of the case, so I'm not sure what happened to the screw. Like I said, someone did work on this before me, evidenced by the screw being lost, and also I think I mentioned that the multiplication mechanism was partially falling off, like someone had taken it apart to try to get to that gear, and then gave up and just half-assed stuck it back on. Anyway, this is a good sign. So let's bring this back up here. And maybe we'll play around with some multiplication. Do 625 times, here they're backwards, so 1, 2, 3, 4, 5, 2, nope. So the issue with that is there's a little lever here on the side that doesn't always go home. Now that it's home, see, it'll work. Did it go home this time? 1, 2, 3, 4, 5, 6. Did not go home that time. So we got 625 times 625 is 390,625. Okay? So the issue with that thing is this guy right here. this guy right here does not always go home. See, it's very slight, but it's just that little tiny bit of movement that doesn't let the multiplication go through. And the reason for that, I'm not sure if I'll be able to show this or not. Because it's in between. It's in between right in there. I don't think you can see it, but this lever, you can see it move there. So there's a slot on this wheel here, and that lever has to go into that slot. And the wheel doesn't always line up perfectly for the lever to go into the slot, and because of that, it doesn't always go in. Now, the reason why I'm not quite sure why this doesn't line up. This is attached to the end of the main shaft, and it looks like for some reason the clutch mechanism down in here is not quite lining things up. Because when you release this and then push it back in place, you can see the clutch mechanism move just a little tiny bit. It's hard to really see what exactly is going on, but it seems like for whatever reason the clutch isn't lining up perfectly. Now it could just be that it needs a little more lubrication. I have dumped lots of oil on this, so I'm not quite sure about that. I might just play with this for a little bit, but I think I'm nearing the point where I'm just going to put the covers back on this machine and leave it as is. I'm not sure how long my fix down there is going to hold up. I did replace I think a couple more of the pins. Some of the ones that I put in before came back out again, so I fixed those, and then some of the ones that I put in got pushed down deeper. I guess they were too short when I made them, and because of that they weren't meshing properly, and they just kind of got like pounded down into the gear and then weren't effective. So I replaced those as well. But I would like to get the covers back on this and do a demonstration with the covers on. So I think I want to play around with this a little bit more. I think this is the last thing that I'm going to be concerned about. I'm not going to really worry about that one column being messed up because I have no idea why it is. I mean, I looked at it and nothing looks obviously off. So, it could be the effect of the carriage being messed up, something being bent that I can't really see. Not quite sure what the deal is with that. But I think I'm not going to worry about it because the machine is perfectly usable without using that column. So I think I'm going to see if I can get this working a bit more reliably, and I think that will be it for this then, hopefully. Yeah, so I got this all back together. I cleaned up the keys and everything, and cleaned up all the face plates. Got these nice red and green decimal indicators here. The keyboard got actually cleaned up pretty well. The paint is still in pretty good shape on there, so it looks pretty nice. So let's see if we can run through a demonstration. Hit 1, 2, 3, 1, so it adds. So we can set that. And it will clear the keyboard each time. We can do 46 minus. That works. We should be able to clear. That works. Okay, so let's try multiplication. So I'll take it off add mode. 25. I just have this side put back on loosely in case multiplication gets stuck again. So we'll do times. Alright, 625 times 625 is 390.625. That's good. Should be able to return clear. By the way, this little thing here sets whether you want both carriages to clear or only the top one to clear. So for example, if I had 46 and I set this, when I do clear, it'll only clear the top one. See, it leaves the counter in place, and then if I put this back over, now it will clear both of them, as you can see. This is different from the later models where you flip these up or down to tell you whether you wanted to clear that register or not, but this one just has that little switch. Also interesting on this one is you can move the carriage manually, which the later models took away. So, let's do a division. We can do shifting it too, by the way. We'll shift it all the way out. So we'll do a division in these columns because I'm not going to worry about trying to fix that column. So we'll do 355, clear just that register. So that's another thing. You can't clear only the counter automatically then. Either you clear both registers or you only clear the accumulator. You can't set it to clear just the counter and leave the accumulator intact like you can on the later models. Another interesting feature of Friden is the power clearing only works when the register is in its home position. So anyway, I got 355 in there. We'll do 113 and we'll do division. Oh, so close. It was just got here and then it got stuck. Let's try it again. If necessary, I can take the carriage off and hopefully just bend that one little tab out a little bit more. It did work before though, as you saw. I'll just try it one more time. Alright, it works. It's not perfect. It's never going to be perfect. Like I said, there's something up with this column that I'm not going to take the time to try and figure out. It could be something, one of the shafts maybe be like a little tiny bit bent or something. The machine is usable in this state. Maybe I'll go back in there and bend out that one little carry tab just a little bit more since it did have an issue on division this time. But that's going to be it for this video. It works. I'm not sure how long that's going to hold up, but at least it got us some time to play with this machine and demonstrate it. These ones, Model Fs and even Fridens of this style, are not very common, so it's kind of cool to get to play around with one. So, fixing a Friden Model F with Paperclips seems to have had an acceptable result so far. Like I said, I'm not sure how long it's going to hold up, but hope you enjoyed this video, and thank you for watching.